Cool. So question is, what needs to make it into a component? Anything that is a cohesive unit of multiple different things. And if that thing has special functions that it can perform, if it has data that's associated with it, you probably want to make it its own component. You do not literally have to put everything inside of its own component. It is perfectly reasonable to have a component that's comprised of a bunch of like paragraph elements and button elements, like base HTML things, as long as they all are grouped up in a logical way and they represent one logical thing. And anytime you want to reuse things between different places in your site, it needs to be a component so you can insert that component in multiple locations. So if I have a table component and I have multiple pages on my site that want to create a table, maybe I put that table inside of a component and then I can use that component in each page and customize it how I want by passing in properties or something like that. So anything that needs to be reusable needs to be its own component. You should not be writing the same thing 3 or 4 times, because then when you change one of them, you're gonna have to change all of them, but you might forget. And if there's something that logically is a grouping of several different items, then you should put that in its own component as well. All right, any other questions? Okay. If there's no questions right now, that's fine. Feel free to speak up at any point, whether it be about something from a previous week or something that we're talking about this week. Or if you're having issues with your homework, feel free to bring that up as well. Can we use nested components? I assume you mean that you have a component that has other components inside of it, which is
Yes,
totally
the
fine.
component inside the components.
Yeah, you absolutely should be doing that. We should be composing our components as much as possible to keep things logically separate. Highly encouraged. So let's just pull up a random website here. I'm gonna pull up YouTube. You guys can look at all the stuff that I have on my YouTube recommended page and judge me for it. So if I were creating this YouTube homepage in React, what I would probably do in terms of component composition is, oh, screen sharing the wrong thing. Thank you. All right, now you can judge all of my YouTube recommendations. So if I were creating this React page, what I would probably want to do is think about what logically is its own function. And I would say that this sidebar would be a really good thing to make its own component, because like this is a piece of very complicated, elements that are composed together. And it also has functionality attached to it. Functionality that's specifically to the sidebar. If I click this button, it opens and closes my sidebar. But clicking on this, that's a behavior of the sidebar. It's not a behavior of anywhere else in my site. So probably I want to create a component that has all of this complicated data inside of it so that we don't make our page component too complicated. But also we can put specifically the behaviors related to this sidebar component. And inside of the sidebar component, I'm probably gonna have a lot of other components too. You see that there's lots and lots and lots of tiles here that I can click on for various things. We don't want to have to like manually define all of these, because if we manually define all of these, then if I want to change one of them, I'm gonna have to go ahead and change all of them as well. since this is reused over and over again with just some minor differences, like the text has changed, the icon has changed, I would probably make this a component. And I would set a property that is the title that you can pass in, and I would set a property for the icon. You can pass that in too. And then my sidebar would be a component of the whole thing, which has child components, nested components, maybe to separate out these lists because we have multiple lists of tiles. So maybe I have a tile list component. And inside of that tile list, I have other nested components like the specific tiles that make up my list and what they do. Does that make sense? Same thing for all these other things. I might have a component for like the main part of my page, like maybe I have a component called video grid. And inside that video grid, we have multiple different components that are the actual videos we're showing. And we reuse a component called video or video tile or something like that. And we can pass properties to say, this is the image you should be showing, this is the text, this is the author, so on and so forth. Okay, lots of questions here. I'm glad. Let's go back a little bit.
So it means like everywhere, almost everywhere in React, we use components.
Yes, I would highly encourage you to make a component more often than not, because it helps logically separate specific things. If I put all of my code for an entire page into one file, it works. It's not very efficient. I can't reuse things very easily. And also, if I want to find a specific thing, I'm going to have no idea where to look in that page. So I should create components that are logically named after the thing that they represent in my page. So maybe a component for a tile widget or a list of tiles. And that way I see on my page, oh, this is what I'm interested in. This is a list. This is my tile list component. So use components more often than not. It's never a bad thing to not make it a component, in my opinion.
So component is like a function in other language, or it's like a module in other language?
There's a kind of, I don't know that it's like a model of a language necessarily, but there's another tool called Flutter that is used to create applications that can run on your phone, whether it's Android or iOS or on the web, all at the same time with one piece of code. Generally pretty cool. I think it's very complicated and very verbose, so I'm not a huge fan of it, but it has a similar thing where we logically group a part of our UI of our page into what they call a widget, but what Flutter would call, or what React would call a component. It's just a grouping of elements on the page that have a logically cohesive function and have behavior attached to them. Jordan, do you have a question? You're unmuted. Okay.
No, sorry, I just accidentally unmuted.
That's okay. I just want to make sure. All right. Let me go back up to the questions then. So we had nested components. Imperative React. Sure, let's talk about imperative React. So if I write a piece of code, I'm trying to figure out where would be the best place to do this. Let's pull up our sandbox here. And let's just write some JavaScript and pretend that we're not in a React project right now. I'm just going to create a basic JavaScript file for a second. Pretend that this is not in any way associated with this React app. So the concept of imperative versus declarative, typically, like at the lowest level of any program, there's going to be code that literally writes out the instructions of what it wants to do. So let's say I have a function here called I don't even know what to call this. Let's create a function that takes a word and reverses it and then prints out the result. And this will take in a string. And what we do is set string equal to str. I think there's a dot reverse function. Nope. Anyway, let's just pretend we had the steps written out here. So I would look at the last character, or let's go even more simple than that. What I would want to do here is I would want to loop backwards through the string, create a new string using the current character. So as we go backwards, we add the last element and then the second to last and then the third to last and so on and so forth. And once I've done that, I'm going to print out my result here. This is imperative. I am telling the computer that I want you to execute these steps in order to achieve what I want to achieve. And at some point in every single program, including a React app, someone has defined code that imperatively tells the computer what it needs to do. This is a very common pattern. Anytime you write just like a normal function, you're writing imperative code. So if I have an application here and I create like a handler on form submit is equal to an arrow function. And normally what I would do here is I would take an event and I would say event.prevent default. And then maybe I call set state something else. Oh, what? Something, 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 and then props dot. What is happening? Blah, blah, blah. You guys have done this before. You've done this in your to-do list where you add a new to-do onto your list from the add to-do form. This is imperative code. Just writing a function like this, you're writing it line by line, it's executing a set of instructions in order. The thing that React does really well is it makes your UI declarative instead of imperative. So if I were to try to create this UI using base JavaScript, it would be a lot of stuff like this, where I am like physically creating an element inside the page, telling it, create this new element and render it to the page. And then I'd be writing a bunch of JavaScript that says, when I click this button, do something. What I can do in React is I can tell in my sandbox here in the render, I can just tell it, give me a button. Let's pretend I have a button component. When this is clicked, I want to execute some piece of code. And then you can put more stuff inside of here, which is other components. Declarative means that I am declaring what I want to happen, but I'm not writing the code that actually like spells it out by hand how it's going to happen. All of that imperative instruction has been abstracted away in a place that we can't see it. It's under the hood. The React developers do the hard stuff for us. All we have to do is declare the UI that we want, and it just does it. If I declare that I want a button component in here, I'm not cared about actually like myself putting it in the page. Someone else is going to do that for me. behind the scenes. I'm just telling React and any other person who's reading my code, especially people that are reading your code, that this is what I am declaring is going to happen. And this is a common thing as well with just like writing functions. If I take a function that's really long and has like 7 different instructions, and I split it up and I write other smaller functions that just are named after what they do, then my bigger function that I've separated into smaller functions, I can sort of declaratively say, this is what is happening. I don't care about the specific details. So let's say I have a function here, or let's just go back to our example. Actually, let's not do that. Maybe I have a function called get most common letter in string. And this accepts a parameter, and I want to return the letter that appears most frequently. So I could write out all of my code where I create a data structure that will count each letter. And then I loop through string. And as I'm looping through, I add to the data structure every letter I find. And then I have something down here that says, check my data structure for the most common letter. And then maybe I do something down here. I don't know what else I could do here. Some other big step. I could write out the instructions for this in a really long function and line by line show you exactly what I mean to do. But a person who's just looking at this function trying to understand, oh, get most common letter in string, what does that actually mean? Or like, how does it generally work? They're going to have to look through all of my specific implementation details and figure out what that actually means. Rather, what we could do is we could split this into functions. So we create a function that we name count letters in string, and this does some stuff. And then I have a function that is get most common letter from data structure. And now what I can do in my main code is instead of writing out all the instructions, I can just call count letters in string and get most common letters from data structure. And this is, again, pseudocode. This is not real code that's going to do anything. But now this function reads that I am declaring what is going to happen inside of this function. So this is something that happens in our React UI, but also a little bit inside of functions. I wouldn't draw on a hard line that React is declarative and JS is imperative. I would say React rendering is intended to be declarative. That's how we create our UI. But JavaScript, it's not declarative or imperative. The code you write is declarative or imperative, depending on how you organize it. In the end, even if you write something that is declarative by saying, I declare that I'm going to count the number of letters, and then I'm going to get the max from that. In the end, these two functions are themselves imperative, because this is going to be a list of instructions, and this can be a list of instructions. At some point, you have to just execute a list of instructions. What we're trying to do is we're trying to make sure that someone who's reading through our code can sort of like read it like can read it like an image of what is supposed to happen without caring about the specific details right there. And we can do the details somewhere else. I would say that declarative code in general is what you should strive for, if at all possible. Like, if there's a way that we can extract the details of something to another location and just make it very clear in English what is happening inside of a function, that's pretty good. But at some point, you just like don't have enough code that it makes sense to split it up any further. When we read through code, I would like to not have to read through 1,000 lines of just instructions that are happening in order and try and piece together what they're doing. I want to be able to read over the highest level of your code and understand very quickly what is happening, what is your code trying to accomplish, what is each step trying to accomplish, and then I can go into each step and look at the nitty-gritty details of how it does it and decide from there. For the purposes of React, really, like, you don't have to worry about this at all. The point the book is trying to make is that React UI is declarative. That's what you should take away from this. Not, I need to write more declarative or imperative code, because in the end, you're not really going to be writing a bunch of crazy functions like this, at least not in the near future. And so this is not something you should be worried about for this class, at least. This is the kind of thing that if you end up working in a software engineering job, like, people are going to review your code and tell you to split things up and refactor your code so that it's easier to interpret at a high level what's going on. All right, that was complicated. Let's go back up in the questions list again. What is the difference between pages, components, and the layout folder? When I say pages, I just mean like the actual web page that shows up. If I'm on YouTube, there's probably lots of different pages. One page is my home page. One page might be the list of videos that I've created, which I think I can get to. If I go to my videos, so this is a separate page. I can go to my channel, that's a separate page. It's just like a logical, not even logical, because it is like a physical thing. A page is like a section of your site that has its own UI. And probably in React, those pages all need to be separate components. In vanilla HTML, JavaScript, CSS, you might have a website where each page is its own HTML file. And those HTML files can link to other HTML files. And those HTML files also have CSS directly applied to them and JavaScript directly inserted into them to make them interesting. With React, React is a single page application. So you only have one index.html, and JavaScript handles like the putting things into the page, taking it out when you go to a different page, putting that content in. There is no physical separation of pages in a React app. We'll get to React Router several weeks down the line, I think. It's not like immediate, but it's coming. And React Router is a library that takes care of that for us. So we can logically think of different locations on our site that have their own UI as pages. But we have to represent those separately in React, which is usually what we would do through a component. Whereas on a vanilla HTML site, we might do it as completely separate HTML pages. That's what I mean by pages. It doesn't always have to mean a component. But in the case of React, oftentimes that's like the highest level component of your website. So a typical pattern is to have your app component here control your router and declare all the different pages of your site that you can go to and any logic about how you navigate between pages. And then each page that you declare in your app component is its own React component, and it's the highest level React component that is an actual UI. And then components, anything can be a component inside of that. However you decide to break it up makes sense. Layout folder, I don't think like having a layout folder is a hard and fast rule. I think when you get to lots of different React components, you should create folders inside of your source that logically group things based on what they do. So I might create a folder for pages. And so if my application has a home page and like a user settings page and like a create a new thing page, then I might create a folder called pages and then put all of my page components inside of there. Maybe inside of that home page, I have several different components that are all on that home page. In that case, I might create a folder for my layout. And then inside of that layout, I might create another folder for homepage. And then inside of that is where I put my components that are inside my homepage. Some components won't belong to a specific page. And so in that case, maybe you just create a components folder. And then inside of that components folder, you create more folders to separate them between like this page, this page, this page, or just miscellaneous. The way you order your JSX files is completely up to you, whatever makes sense based on your application. There's no right or wrong to do. Okay. Next question is from Laura. Since there are a couple ways to deconstruct props, how do you choose which way to go? The answer is whatever the hell you want. There is no correct way to do it. It's whatever makes sense to you and looks cool. I personally undo all this stuff that I changed really quick. All right, I'll get rid of this. Cool. So if I have another component here, let's create a sample component really quick. And I create a function sample. And let's say this sample component is part of our UI. And I'm going to pass it a couple different properties. Maybe we'll pass it some data equal to 1, some function is equal to a function that just does console.log hello world. Cool. So I have this very, very simple component here, and I'm passing a couple properties. So again, I can declare these props however I want. I could declare a props object. And then inside of my thing here, I return, let's return a paragraph element, and we'll put props dot some data in here. And this is going to tell me that I have props validation, which I hate. I'm just going to go ahead and fix that. What do I need? I need prop types. Cool, and that'll make it go away. And then maybe I have a button here. And on click, I execute props.sum function. And I'm going to put this inside of a fragment because we can only have one parent element. Cool. So this is our sample component. Let me run this really quick so we can see this. Come on, you can do it. Nice. So I have my data down here and I have this button. When I click on it, theoretically, it'll print hello world. Cool. So we know that works. This is not important. I'm going to close this. So we could do this. Generally, I don't think this is a great way of doing it because you're not declaring to anyone what properties you have until you get somewhere into your data. I personally prefer to declare up at the front what properties I'm expecting so that I know where I can change it if those properties change. So I could destructure by doing destructuring inside of my component. And then I can get some data, some function. And I think you can also set defaults if you do it like this, which is cool. So let's say I forgot to pass in these properties. It'll give me a default of 0 or a default of do nothing, which is sometimes useful. And then down here, I don't have to do props dot anymore. I can just do some data or some function. This is totally fine. Feel free to do this. I also will typically just take props out and just do it as part of the component definition. You might even put it on its own line. I've seen this before just for organizational sake, but I think it's gonna collapse it for me. This is also totally fine. Whatever you think is more easy to understand and less cluttered. But I like to destructure my properties rather than not, just because it makes it clear at the very beginning to someone who's reading the component, this is what my component needs to be able to do. So take your pick and stick with it. You don't have to do it differently for each component. All right, can a React project not have a parent but only children? No. In the end, the parent of every single React project is this root element. If I go into my page here, this root element gets inserted at the very beginning, and then our app is rendered inside of that root, and everything inside of the thing is rendered into the app. At some point, you have to have a parent. You have to have this root element inserted into your single index.html, and then React edits all of the content in here on the fly using JavaScript. But there will always be a parent. You cannot have a component that doesn't have a parent. Something has to render it. Root is the parent of the whole application. App is the parent of all of these components inside of it. So your app component in this case is like the second level. We are creating a root which takes this app and inserts it into this root element. And this root element is declared inside of your index.html. This has to be here. If I take this out, React's going to explode. So your root is your highest level parent, and then app is the highest level component that we're inserting using JavaScript. How do you incorporate Bootstrap with React? There are lots of different CSS libraries that you can use in React. I think the easiest way is to just Google Bootstrap React setup, and someone will tell you how to do it. But it is always possible. Another one that people are very common to use is Tailwind. Tailwind is a CSS library that instead of like creating an index.css file and then going into my my main.jsx and import the CSS file, we can actually like declare inside of our component definitions what styles they need to have using classes. So I could say class name is equal to text large, and Tailwind is smart enough to know, oh, text large means that this text needs to be of size 12-point font. So they've created all kinds of classes for you, CSS classes that apply one specific styling. and you just put the class directly onto the elements. I think it's pretty cool, but it's also really, really verbose, and so it's not for everyone. TypeScript can make things harder, especially in the case of your to-do list item app. You're not writing a lot of code, and so the effects of TypeScript you don't really feel, and it's just extra boilerplate. But I personally would not create a production application that I'm going to send out to the world in vanilla JavaScript. I simply would not do it because it adds so many benefits when you're writing the code to make sure that you cannot possibly have a type that is different than what you expect. In JavaScript, I declared this property up here, some data, and I'm assuming it's an integer, but React does not stop me. JavaScript does not stop me from passing a string or anything like that. And if I'm expecting it to be an integer in my code, then that's going to lead to some crazy, crazy bugs. But TypeScript lets me say, this has to be an integer. And if I accidentally pass it a string somewhere else in my code, it's going to tell me before I even run my code that I can't do that. I think Tailwind is probably a little, I don't know if it's easier to use, but it's more customizable. I think Bootstrap is really good at giving you things that look good, like bigger components that already look good and are pre-styled. Tailwind is just a way of writing CSS for your own components faster and more efficiently. It doesn't give you any components that are already styled to your liking. I think Bootstrap is more comparable to something like Material UI, which is a component library. So it's not exactly the same, but it's a component library that gives you React components that are already styled, already functional, and you just have to plug and play them in your application. And you don't have a whole lot of control over how they look, but they look good enough that if you're just trying to get something up and running and you don't want to rewrite the wheel, then you can just use those. I do not know what framework or library you would be talking about for auto typing for JavaScript. The only thing I can think of would be like auto completion, which is usually an extension of VS Code. There's also extensions for snippets. Like if you have, I think what they do is they have pre-generated or pre-written code that you can start typing a shortcut and it inserts that little snippet. And it's snippets that you write over and over again that are pretty useful. One cool thing that I can do in VS Code is if I write just an exclamation point and then I hit enter, it will generate HTML boilerplate for me. I don't have to write that all out by hand. I can do the same thing with free, which only does the doc type. Snippet extensions do that same thing, but for other languages and more complicated stuff. What type of app should we not build with React? I don't know. I think once you're comfortable with React, you should build everything in React or in a different language. Not a different language, different framework. The point of React is not like to say this is a specific kind of application that you always need to build in React. It's a tool that if you have something you want to write, you can write things way faster than if you were doing it in vanilla JavaScript and CSS and had to like deal with all these crazy interactions about, well, I got new data, so like what needs to change? React just knows what it needs to change for you. You don't have to control all that yourself. There might be a case where a different framework is better suited for the application you're making. I don't have any specific examples, but there's all kinds of frameworks that do really cool things. I've heard in the past that something called Svelte, Z-V-E-L-T-E, actually maybe there's no T at the end, is really good at creating really cool like web visualizations because they have a couple of features that are really useful, but it's not as suitable for other types of applications. People on Google can compare and contrast much better than I can. So I would say I don't think it's ever a bad thing to use React. Maybe there's a different framework that's better suited, but unless you know what it is, there's no way of knowing. Can you use Bootstrap and Tailwind together? Probably. I don't think that I've done it, but I think you can. Bootstrap would give you stylings for some components, but I would guess that they have ways to add even more styles onto the components other than what Bootstrap puts on there. You might have to fight against Bootstrap in that case, but I would guess that you'd be able to do that. And Tailwind is just a way of adding extra styles. So that if you have things that aren't bootstrapped, like if you have elements that you create on your own that aren't given bootstrap classes, then you can use Tailwind to add other classes, or you can just add your own classes, whatever you want. I have no idea what most websites are built on these days. I would say that from my experience of what I've seen, I think React is the most commonly requested web development framework. Like from job postings I've seen. Maybe something like Angular is also pretty commonly used. But I don't know. I don't have a good answer for that. How do you test your React app? That is a great question. And it's something that I want to talk to you guys about, but I want to do it a day where we have a whole hour to like really jump into the nitty gritty. Generally, what you'll be doing is you will be testing that your components render correctly under certain scenarios that you expect them to render a specific thing. You'll be testing that functions that you write that just like perform a little algorithm actually, given specific inputs, produce the correct output. You'll be testing that if I open this page and perform these series of actions, it produces the expected result. You are testing anything about your website that you can automate so that when you break it in the future, it's very easy to notice that it's broken and fix it. You should not have to wait for a user to come to you and say, this was working and now it's not. Ideally, any issues like that, you would write a test, and when that bug comes in that causes that problem, you can run your tests and see before you release the code that I've caused a problem and I need to fix it. How can you guess what will break? What you'd want to do, there's this thing called test-driven development, which I think is sometimes stronger than what you really need. But the point is when you're writing code, before you release that code for the first time, you should write all of the tests that you think prove that your thing works. So if I have a function, let's write a function really quick. Count number of A's in string. I think we actually did this last week, so I'm just gonna copy this out and put it in its own function. str, and this will be str.length, str, count plus plus, return count. All right, so I have a little algorithm that I just wrote. I may be using this somewhere else in my app. I want to make sure, I want to write tests that will automatically run before I release my code that can prove that this function always works. So I would write unit tests for this function that tests this individual unit of execution, this one singular thing to make sure it works correctly. So I might write a test that, so tests that I would want here would be anything that I think could potentially break my code, or specific cases that I was thinking about when I wrote this code that I want to make sure I got correct. So maybe one case, the base case we want to test here is that some random string returns the correct number of A's. And this one, I see 3. So if I run this function with this string, it should return 3. Other things I'd be interested in. An empty string. What happens if it's an empty string? Well, I should return 0, but do I actually return 0 or do I return something else? Maybe I introduce a bug in the future that starts counting the wrong thing. In that case, we should have a test to make sure that an empty string works. This is an edge case, something that might be unexpected and cause problems for your algorithm. I also, very carefully in here, am counting both lower cases and upper cases. So I probably should have a test that correctly assesses that it checks and counts both lowercase and uppercase. So maybe I write a random test here, and this should be 8. And if this ever returns 4, then I know that I probably didn't do this correct. So this is a specific part of my code that is a complexity that I'm thinking about when I'm writing this code, and I want to write a test for. And so I'll write a test, and I'll just run all of my tests using one command, which is usually built in here. I think I've removed mine, but you can write a script that just runs testing commands, which you'll have some tool that runs the tests for you. Usually Jest, I think, is the one that's most commonly used for JavaScript. And it'll run every single test that you've defined. And if they all pass, great. We accept that our code probably works. We might need some manual testing by hand for things that we can't automate. And we don't want to immediately throw the code out in the wild, but we can be pretty sure that this function continues to work. And in the future, if I accidentally delete something here, like maybe I accidentally replace this with a 0, then this test or these tests are going to break, and it's going to show me that something happened. There was a regression in my code, and I need to go figure out why these tests aren't working and fix it. So that's why we write tests, and then you'll run them typically through a command, and then in any kind of automation you have that takes your code and puts it onto your server somewhere way out in the cloud. Before you actually deploy your code to that server, you want to run those tests again, just to make sure one final stage that everything works. That way you can do it by hand while you're writing the code, and also you can be sure before you put anything in production that it works. When the dev knows that you wrote enough unit tests, it's a common sense thing. You should not be writing 100 tests for something as simple as counting the number of A's. You should be writing tests that sufficiently prove to everyone that your code works. And you probably will not get every single test that you need on the first try. Maybe you write 3 tests and then you put your code out in production and someone finds a bug with it. Well, you fix that bug and you add another test specifically related to that bug you fixed. Maybe I didn't have this test originally about casing, and I had a bug, and the rest of my tests were passing. But when I put it out into production, someone found out, hey, there's an uppercase A in here that's not being counted. Oh, let me fix that code, and then let me write a new test specifically for the fix that I made. And now this test will prove that our bug was fixed. And we keep adding tests as we make more changes. It's never like you're done after you write the test right at the beginning, but you should, when you write the code, write enough tests that you can sufficiently prove that it works, and add more tests as you add more code to that thing in the future. You should stop when it feels reasonable. Don't go overboard, but also don't take the easy route and not write enough tests and hope that people don't notice. The whole point of these tests is for you to safely deploy your code and have peace of mind that it's going to work. This is for you. This is not for your users. This is for you. There's different kinds of testing, as Jenny is pointing out here. What we're doing here is a unit test. We're taking one unit of code, which is usually like a function or a method, and we are individually testing this with a bunch of inputs, outputs, and making sure that it works. So this is a unit test. We also have integration tests, and we have end-to-end tests, and all kinds of other tests. Maybe we want to like make sure that our data is consistent. There's lots of other kinds of tests. These are the three most common, I would say. And all of these should probably exist in every single application that you create. A unit test is going to be your most common type of test because it's the easiest to write. You don't have to worry about anything else working in your system. You only are testing one small little thing. And generally, they're really easy to write, and you'll have thousands of them over your entire application. Unit tests are super important. It's like a pyramid. I think we can actually, yes, testing pyramid. Maybe it'll give us a good example. Yeah, so it's like a pyramid. Our unit tests are at the very bottom of our pyramid because they are the easiest to write. Open a new tab. We'll zoom in here. Integration tests take multiple different parts of your system that are either connected by like a data flow or by function calls or just in some way related to each other and have compounding effects on each other. And tests that if I start with the beginning of my unit of related things and I perform some action to it, I should have the intended result. So maybe I have like a function that calls other functions that call other functions, and it all comes back and produces a result. In that case, I write an integration test that says, call this initial thing, wait for it to finish, and then prove that I have the expected result. In the end, it does something similar to a unit test. You give it an input, it does something, you test the output to make sure it's what you expect. But this is more complicated because there's multiple different pieces. You have to know that each of those pieces individually work, or you're expecting that they individually work for that test to work. If your test passes, but there's problems with your unit tests, well, then you've written a bad test. Your unit test should fail to identify that your individual components don't work, and then your integration test should be showing you, do these things work correctly together? But oftentimes it will require you to work around or refactor a bunch of code or sort of like replace code that does something with just like a dummy thing called a mock that does nothing. A mock is something where we take a component that maybe like makes a web request or interacts with our database. And in a test, we don't actually want to do that because we don't expect that it's going to work. Or we don't have the context of our application about where are we making that web request or what kind of data do we want. Or we don't want to actually like do anything to our production database, in which case we would make a mock that says, when I try and do this thing to you, when I try and run this code that makes a web request or makes a database edit, then my mock just replaces it by saying, whatever, I'll just give you this piece of data that you're expecting and we'll pretend like it all works. And so you typically will have to create some mocks in order to make sure that your integration tests work, because there are certain things that you can't reproduce in a test that are a part of your actual production site. So it's a lot more complicated. You generally don't need as many because you're not going to have as many integrations as you have individual pieces. If you have an integration, you have at least 2 components, and those 2 components should have unit tests. So you already have more unit tests than you have integration tests. And then end-to-end tests is like highest level. If I push a button on your page, is it going to take me to the right place? If I click login, is it going to correctly go to the database and log me in and stuff like this? And this is something that you would, I think, most likely do like in a testing environment, like running your code in an actual environment, like in a real web page. So like integration unit tests, you execute, you write in your editor and you execute before your code ever hits production. But you would send your code to a testing environment and then run your end-to-end tests that pretend like they're users and interact with your page. And you can automatically, when that interaction is finished, test that your page is in the state that you expect. And these are going to be very few because they're even harder to make sure work. And by that point, your integration unit test should guarantee that most code already works. So you need all 3, the most unit tests, the least end-to-end tests. How you write these, we could talk about that in a future week, but I don't want to do that today. Yep, you could use a mock and a unit test if you really need to. Mocks are just generally useful things. I don't have a good example right now, but I can pull together an example for a future week when we actually like write some tests. I want to maybe next week if we can, or maybe we'll wait until a review week, like actually take our to-do list app and write some tests for it. And show what the process is, how we actually decide what becomes its own test, and the process of, I wrote this piece of code, how do I write tests for it? What does that tell me? And we'll like go through and actually do it as part of our to-do list app. So I don't know when that'll be. I have plans for it. I was going to get to it today if we didn't have questions, but we had lots of good questions. So we'll do that another week. Cool. This felt really productive. Lots of really great questions. Thank you all for giving me fun stuff to talk about. I will stay on as usual for a couple minutes. Just make sure if you have any questions, feel free to stick on. Otherwise, you're dismissed. I will talk to you guys next week. Have a good weekend. Have a good night.
Thank you. Have a good night, everyone.
Thank you. Good night.